Okay, so rather than bore you and sit here entering a bunch of numbers, I decided to pause the video and just enter them and then start a new one. I also didn't want the other video to get too long and maybe have an interruption that I'd have to restart the video because I don't feel like editing. But all I've done is I've taken the data from this table, I've entered it onto here. We're going to look at the median birth weight and the shape of the distribution, and then which measure of central tendency describes the average birth weight better. So let's go ahead and do second quit. Stat, we're going to look at the mean and median. The mean here is 7.488. That's probably right since that falls somewhere in the range of these numbers. We don't have like a giant number that's throwing these off. And then the mean is that, and the median is 7.35. So then that means the mean and median, I don't know, is this justified as close enough? It could be. We didn't really establish much of a boundary to what's close and what's not close. Although I think in this case we have the mean being greater than the median, which means skewed right. I would think it's skewed right, and the reason I would think skewed right in this case and not symmetric is that these birth weights, there's so many in a specific area that it almost begs me to think that a little bit more of them are falling on the left. So with that being said, I'm going to make the assumption that this is actually skewed right, with the mean being greater than the median, and not where they're equal, even though they're relatively close to each other. So let's move on. We've done this one. Determine the mode for the data. The mode is the most frequently occurring observation. If no piece of data is repeated, we say that the data has no mode. If one piece of data is the most repeated, we call that the mode. If more than one piece of data is observed the same number of times, we declare multiple modes. So for instance, if you have 5 1s and 5 6s on a list, and 5 is the most number of any number, so 5 1s, 5 6s, 2 2s, 2 3s, and whatever else, just not 5 or more, then what we would say is the mode is 1 or 6. Let me write this out for you and kind of give you a heads up. So I am going to go, I have 1, this is my list, 2, 2, so if we have this list of numbers, we'll notice there are 5 1s and there are 5 6s, and everything else is less than that. So the mode here is 1 and 6. We call this bimodal. So we have bimodal, and it's 1 and 6. If we look at the median, that was probably the 2. It's this 2, because there's 5 1s, 5 6s. These two go together, and so the median here's 2. But since we're talking about mode, what if we had 1, 1, 2, 3, 5, 4, 6? Then the mode here is simply just 1 for this example. And if no number is repeated, then there is no mode. Okay, so just keep that in mind as well. Once again, if we look at this example, we have a lot of zeros. 0 is the most repeated, so therefore 0 is the mode with 11 frequencies. And since 1 only has 4 frequencies, we don't even need to mention it. Find the mode of the data set. And since no data is repeated, that means there's no mode, so we'd be done with that one. And determine the mode. The mode location of injury is on the back, and so that's if it's qualitative. It's just the one that appears the most. Hopefully these sections are not too bad for you guys. It's really just comes down to understanding the terminology and how to apply it. Learn how to use your calculator, and everything will be good for you on these. while it's not usually necessary to use it for this, it's just way faster, and it gives you practice because you will want to use the calculator for the stuff we're going to do towards the end of the class. I hope these videos are helpful. Make sure you reach out for help if you need help. Thank you guys for watching.